From the earliest days of flight, aviation has drawn heavily upon new and changing technology. The change has become more rapid since the advent of the computer, placing aviation on the leading edge of technology. New technology is wonderful, but when you're traveling at 500 miles per hour in a tube 6 miles above the Earth, you don't want to be part of an experiment. Fortunately, you're not. That's the job of the scientists, engineers, and pilots at the FAA's Technical Center in Atlantic City, New Jersey. And this is where the rubber meets the runway. The FAA's test fleet ranges in size from a single-engine home build to a Boeing 727. Engineers put devices through a grueling series of tests to make sure that there are no surprises when the equipment is installed on commercial aircraft. We visited the Tech Center to see how testing is done. On this particular day, the flight crew was assigned to test a TCAS system. That's short for Traffic Collision Avoidance System.
TCAS is a transponder-based technology which allows one aircraft to know the location of the other. In the case of TCAS 1, it'll be able to determine the position of the other aircraft and determine if it's going to come within a certain area, which can generate an alarm to the pilot. TCAS 2, on the other hand, when it comes across the transponder-equipped aircraft, it'll compute from the other aircraft's transponder the range, bearing, and altitude, and give the pilot, if necessary, an indication which way to escape.
Descend. Descend now.
Versions of TCAS have been around since 1955, but each time the technology advances or the device is used on a different type of aircraft, it must be retested in order to be certified for use on commercial aircraft. Today, the crew is testing the older version of TCAS, TCAS 1, but on a helicopter.
The helicopter, because it flies slower and because of its unique abilities to stop, and the guy can hit a rudder pedal and turn 180 degrees around, the TCAS systems were just not designed to work under those circumstances. They were designed with the idea that they were going to be installed on a standard fixed-wing aircraft.
To test the accuracy of the equipment, the FAA is using two aircraft, a Convair turboprop and a Sikorsky S-76A helicopter.
Clear left, nobody's around. All gauges look good, John.
Okay, on this test we were doing some head-on encounters, trying to gather data for the engineers, looking at the, in this case, where we have the TCAS antennas placed on the helicopter.
This computer here records all the data coming out of the TCAS system, which is switched back up in here, and will be displayed here.
Can you give me a hand finding him here? Okay, he's right side, Kevin, slightly below us, just coming across right up the shoreline, about 1 mile away.
Oh, there he is.
Doing head-on encounters with aircraft sounds uncomfortably like a game of airborne chicken, but the moves are choreographed down to the last detail.
With the group that we're with, the 7 pilots that are constantly flying this, we all are like a family, and we all know each other's reactions and how we fly, and it really becomes, there's really no tenseness in it at all.
We've always been very close because we've flown a lot. When we go out on travel together, we usually go out and eat together. We know about each other's families. It's a very close, tight-knit group of people within the hangar.
You can see me, he's above the horizon at about 11:30, almost 12. Tally ho.
Yeah, was that close enough for the guys?
You happy with that, Kevin?
Yes, it was excellent.
After making several close passes, the team decided they had gathered enough information. But the work was far from over.
The results of the flights obviously come from sitting down and analyzing the data, and anything that comes from a program, other than all the inputs from everyone participating, the real performance of these systems are evaluated by that data which has been collected during the flight. We need all this minute data to be analyzed to just see how well a system can perform, not only in an environment here at the Tech Center, which is relatively benign, but in those areas where we sort of overstress the system.
We can be looking at files on the order of 16 megabytes.
As scientists are busy analyzing the data for this project, the FAA pilots are on to their next assignment.
We have, right now there are 7 flight test pilots in our group, and we all have various projects. TCAS is just one of them. We have a lot of different projects, GPS navigation. We have some weather studies involving aircraft. We also have ancillary responsibilities whenever there's radio frequency interference at centers or approach controls. We may be tasked to go ahead and locate that interference.
Just another typical day in the life at the FAA Tech Center. And as for TCAS, has this technology reached its limits? Hardly.
Well, the number I'm hearing now is TCAS 4. And this would be the TCAS 2 as it now exists, but it would be augmented with a new surveillance scheme, with a GPS in particular, a satellite-based system. And what that would give TCAS would be a very long range. Like right now, the system is guaranteed from up to 14 miles, and we have seen fairly good performance up to around 30. But now we're looking at a technology that can give us ranges in the excess of 100.
Aviation technology continues to develop at a rapid pace. But next time you're flying high above the earth, you can take heart to know that every part of the aircraft has been checked and rechecked by the dedicated scientists and engineers at the FAA Tech Center.